To kick off the afternoon, it is my pleasure to introduce Neha Narula. She is the director of the Digital Currency Initiative at the MIT Media Lab, which leads research into cryptocurrencies and blockchain technology. While completing her PhD in computer science at MIT, she built fast, scalable databases and secure software systems. And she has spoken about these topics at dozens of industry and research conferences, including the 2016 TED Conference, where she spoke about the future of money. She is a member of the World Economic Forum's Global Future Council on Blockchain, and she was previously a software engineer at Google for nearly 8 years. Please join me in welcoming Neha Narula.
Thank you.
Thank you.
Hi, everyone. I'm very excited to be here. So thank you for that lovely introduction. Let me make sure that this is working properly. Great. As Nathan said, I'm the director of the MIT Digital Currency Initiative. So we are we are part of the Media Lab, first of all, and we're MIT's research group on cryptocurrencies and blockchain technology. We work on many different aspects of this tech, from financial inclusion to technical scalability to privacy. And in particular, we have a soft spot for reforming the financial system. And I'd like to start by talking about our current financial system. There are so many inefficiencies, and one of the worst ways this manifests itself is in how expensive it is to be poor. Oftentimes, the poor don't have access to financial services, or when they do, they get hit with the highest rates and the highest fees. Quite simply, our financial system is not serving everyone. And we can see that in many different areas. There are a lot of people who don't have access to credit because they don't have traditional credit histories, and so therefore they don't have a credit score. And it's basically like they don't exist in our financial system. Rampant fraud reduces access to capital for many legitimate small businesses. And in some areas, contracts are actually unenforceable. Oftentimes, rural communities are without access to basic infrastructure because they simply can't get the investment that they need in order to build that infrastructure. It's not profitable to invest in these small communities. So why are things like this? Well, right now, everything we do with money is mediated by commercial banks. They set the terms, and our choices are quite limited. But it's not just finance. So the public's faith in institutions is actually already at an all-time low. So Gallup tracks confidence in institutions. And here I'm showing only the bottom portion of their list. So this is the list of institutions in which the public has the least amount of confidence. And banks are bad. They only have 28% confidence, but they're not even the worst. There are problems in publishing, in big business, in our criminal justice system. Congress is at the bottom with only 8%. Now, one commonality is that all these institutions are structured in a top-down, hierarchical way, and people don't really have enough visibility into how they work, so they don't trust them. This crisis of faith is leading to new ways of imagining social institutions. And it begs the question, how can we coordinate without institutions? Well, inspired by cryptocurrencies like Bitcoin, we're finding new structures to think about how to organize, and they're not the traditional hierarchical ways. In 2008, a mysterious, shadowy figure known only as Satoshi Nakamoto released a paper, and shortly thereafter, he released the code of a working system called Bitcoin. So Bitcoin is the world's first cryptocurrency. Satoshi just kind of dropped this paper on the internet. We don't even, contrary to popular belief, we don't actually have any proof as to who Satoshi Nakamoto really is. And what Bitcoin was it was the first time that we had a real way to do digital payments without a bank. So this is the paper that was released in 2008, where Satoshi outlined the design for Bitcoin. Today, Bitcoin is many tens of billions of dollars in market cap. And I want to draw your attention to the beginning of the abstract. A purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. Now, I think that oftentimes we don't really think about what that statement really means, but it's actually quite novel. Up until Bitcoin, we did not have a way of doing digital payments without a bank somewhere in the middle. This was the first time that we were able to completely circumvent the financial system. So what I'm showing you right here is I'm actually showing you the very beginning of Bitcoin. This is what's referred to as the Genesis block. You can see it in hex here. There's a lot of different data. But the place where I want to draw your attention is to this part right here. So Satoshi embedded into the very first block of Bitcoin, the Genesis block, this headline from the Times, January 4th, 2009. Bailout of banks, Chancellor on the brink of the second bailout for banks. I think, he did this for a couple reasons. So one reason was to prove that he hadn't created Bitcoin a long time ago, that it was actually created after he saw this headline, so after January 4th. But also, this spoke directly to growing concerns about the consolidation of power into a few institutions which are too big to fail. So looking at systems like Bitcoin, we raise the question, can we take closed, consolidated systems and turn them into open, distributed systems, something that looks a little bit more like a commons? So there are a few really important things that we can learn from Bitcoin. The first is that we can build open admissions, rationality-based systems that get distributed consensus. Now that's a mouthful. What do I mean by that? Bitcoin's open admissions in the sense that anyone can join. You can go download the software, start running a node, become a miner. Anyone can join the system. This is pretty outrageous, actually. And the way that this is secured is using rationality. So we actually use game theory, mechanism design here. Bitcoin is kind of this elaborate game that's designed to keep the system secure. And what this allows us to achieve is this thing called distributed consensus. So globally, around the world, people can agree on the value of what the Bitcoin ledger is. And people are really excited about applying this to a lot of different areas. Another really important thing about Bitcoin and that Bitcoin showed us is that it's the power of giving anyone the ability to validate and audit the data. Now, this isn't how our world normally works. We don't have access to all of our data all of the time. It's usually locked up in companies' data centers. Bitcoin's the opposite. It's inside out. All of the data is out there, which means, yes, it's public, and there's work going on to try to address that issue. But also, it's transparent. Everyone can go back and see for themselves how the data has evolved and make sure that it actually makes sense. And we can apply these ideas to more than just payments. For example, transferring digital assets more broadly. Academic certificates and credentials. We have a project going on at the MIT Media Lab called BlockCerts, which is about how to take your credentials with you. So even if the issuing organization goes away, you can still prove that you had them. There are some people exploring the integrity of data like land titles. We also have projects where we look into things like portable healthcare records. And I think most interesting is that this technology gives us the ability to do something called fair exchange contracts. So you might have heard this referred to as smart contracts. And the idea here is that either a contract happens in its entirety or it doesn't. There's no way for one party to kind of cheat the other. These things are automatic, they're written in code, and they execute atomically. Now, I want to dive a little bit deeper into a non-monetary example here. And this is a topic that has been kind of gaining a lot of steam. A lot of the old guard of the internet, like Tim Berners-Lee and Brewster Kahle, are talking about re-decentralizing the web. Okay, what do I mean by that? Well, the web started as this free, open, peer-to-peer system for publishing. It was incredibly democratic. Anyone could publish and connect. We could reach each other around the globe. You could comment on any blog post. We had all of these wonderful open protocols. Unfortunately, this didn't really last forever. So how many of you guys take pictures with your phones? Pretty much everyone, right? Now, where do you put those pictures? So my pictures are pretty much everywhere. They're in Instagram, Dropbox, Facebook, Twitter, and these things don't work with each other. We've sort of left behind the ideals of the web where we have these interoperable protocols where people own their own data and they can access their data through many different means, and instead we've moved into this world of apps and data silos. And these silos are disconnected. All of these different services are in this race to capture our photos, and none of them actually work together because it's not in their best interest to do so. So the web has evolved to contain what we call these mega platforms, these super large companies, Google, Amazon, Twitter, Facebook, that mediate a lot of our interaction today on the web. So why is this something to think about? Why is this concerning? Well, it's led to a world where 81% of online news traffic in the US is sourced through Google or Facebook. Facebook is the most dominant source of news on politics and government for millennials. It's what television is to the baby boomers. And this is worrisome because we've already seen sort of some very disturbing things happening on the Facebook platform. We've already seen some bias, right? There was this article about how Facebook contractors were told to suppress conservative news in trending topics. We like to think that algorithms are neutral, but as I'm sure a lot of you know, they're not. They encode the values of the people who create them. So of course Facebook is biased in many different ways, and we've seen many different instances of this happening. But it's not just bias that's the problem. It's not just curation. There's also outright exclusion and censorship. So this is a tweet by Jillian York, who's an activist for the EFF, and she got banned from Facebook for 24 hours by posting pictures of a breast cancer awareness campaign that included actual breasts. So, okay, she's banned from Facebook for 24 hours. Well, what is that for 24 hours? What does that really mean, and how much damage is that? Oh no, you can't like your friend's posts. Too bad. Well, actually, it's surprising all the ways that Facebook has kind of crept into our lives, and if you're not careful about it, getting banned can actually have pretty serious repercussions. So Jillian found she couldn't comment on news sites. There are a lot of news sites that just use Facebook comments, for which you need a Facebook account. She couldn't log into apps that she had connected to using Facebook Connect, which is actually a tremendous number of them. And Facebook Connect is this way of simplifying account logins. So she couldn't listen to music, she couldn't date, she couldn't get on Tinder. Obviously, you can't see your photos, events, and contacts that are stored within Facebook. And she found that she couldn't even administer Facebook pages that she needed to handle for her work. So what's the alternative here? Facebook and Google and Twitter are quite the behemoths. Well, the alternative is open protocols, going back to what the web was really supposed to be about. It was supposed to be about these open protocols that many different types of applications could leverage, which put users in control of their own data. And here are just a few of them. But to be frank, none of these have gotten anywhere near mass adoption. None of these are anywhere close to what Facebook, Twitter, and Google are. And that's because there are actually a lot of benefits behind consolidation. And it's very difficult to make open protocols really work. So first of all, there are a lot of benefits to users. There's security and integrity. We trust Google and Facebook to keep our email safe, to keep our login credentials safe. We trust them not to show us spam. These systems are also more user-friendly, whereas open protocols mostly aren't. A lot of open protocols require users to run their own servers or to set up their own endpoints. And we've sort of created this freemium model on the internet. So users have access to these really high-quality, free services. They don't have to pay for them, and they're used to that. There are also a lot of benefits to the companies. So first of all, they can hoard all of our data and they can monetize it. And in fact, there's an incentive for them not to work with each other, not to share data, not to make things interoperable, because if they do, then that's sort of one less bit of grip of control that they have on our data. I don't know how many of you remember this, but in 2012, you could actually view Instagram photos on Twitter. And then what ended up happening was Instagram banned that because they didn't want to lose eyeballs. They didn't want to lose your precious photos to Twitter. They wanted to control what the users saw. They wanted to make the users come to their application. Also, and because they need to monetize data, well, they need to monetize data. They need, the entire business model of the web is based on advertising, and so this is the way that they get funding. They get funding by creating a viable business which can turn a profit by getting eyeballs. Also, these companies benefit from economies of scale. So the bigger you are, the more storage and bandwidth you buy, the cheaper the price. They also benefit from control. It's much easier to innovate on top of a closed system that you control top to bottom than it is to innovate on top of an open protocol. It took a very long time for the web to move on to HTML5. It's still in process. We're moving from IPv4 to IPv6. It's very, very difficult to innovate on top of these open protocols, and so that's a real challenge. So we're seeing something really interesting happen. I want to bring this back to cryptocurrencies. So Bitcoin and Ethereum were the sort of original biggest cryptocurrencies. But people are actually experimenting with creating dozens more, and they're calling these tokens. And the idea here is that this is a new mechanism of funding protocols. So everyone here, every single one of these companies has released a token or is about to release a token, and they're using that token to fund the work that they're doing. And these applications are at all different levels of the stack. Some of them are about file storage. Some of them are about identity. Others are about algorithms. It's very, very, very interesting to see this economy developing. Now, what's really great about this is that tokens potentially provide a new way of funding that is completely different than advertising. You are literally funding the protocol directly that you've created. And this leads to a lot of really nice features. First of all, unbundling layers. So instead of an incentive for an application to own the stack top to bottom, we have the ability for a protocol to just be one part of the stack. They can still monetize that. They don't have to get all the way to the end user. There's also more of an incentive for data portability and interoperability. Again, they give users the ability to verify their digital data and transactions. And most importantly, I think, is that it's a mechanism for incentivizing open protocols. This could potentially be a way of funding open source software. Now, this idea, I think, is really powerful. We haven't really seen anything like it before. It's taking the ideas behind Bitcoin and Ethereum, behind cryptocurrencies, and applying them to a lot of different applications. Now, the question is, will this work? There is still so much we have to figure out. We're still in the infancy of this space right now. There are many different challenges. So one of the most important challenges is avoiding scams. So this is a Reddit post by someone who was working on one of these tokens, a developer. And what happened was the CEO basically ran off with all of the money that they had raised after they did a token crowd sale. And so this developer posted here, like, I'm really sorry, I've lost all faith in this project. I don't know what's going to happen. He just took all the money and ran. And this is a serious issue. Right now, we're definitely in scam territory. Some of these things are real. Some of these things are not. Users who aren't very sophisticated might get taken advantage of, and this is happening every day. But I'm kind of, I'm not as pessimistic as you might think, because apparently when equities first came to be a thing, when stocks were first issued, there was also an issue with scams, with people pretending to have companies and issuing shares of their company. And we managed to figure that out. We have organizations like the CFTC and the SEC, and I feel confident that something will evolve in this space that will make sense, that we'll be able to work together with regulators to find a way to safely issue these kinds of tokens. Another major challenge is these systems run on this principle where we've removed human intervention and human regulation and instead are basically treating code as law. And this can be a very bad thing. So this headline is about a contract that was basically an investment vehicle. It was referred to as a DAO that was run on the Ethereum network. It's very interesting because the developers of this investment vehicle basically said the code is the specification. Just read the code, that is exactly what this investment vehicle is supposed to do. But of course, we're humans. We don't parse code that easily. We sort of have a more higher level abstract sense of what an investment vehicle is supposed to mean. I put in my money, we all vote, and then that money gets invested as the majority vote. That's kind of what I think of when I think of an investment vehicle. Unfortunately, there was a bug in the code of this contract, which led to an attacker draining about $60 million worth of the cryptocurrency Ether from the contract. At today's prices, that's actually worth closer to $800 million worth that was drained. Arguably, you might not even want to call this person an attacker. They just found a really nice part of the specification that they could take advantage of to try to take this money. So there are a lot of things that we need to worry about when we use the paradigm of code as law. But I'm not super worried about this either. I think that with tools like formal verification, with designing smart contracting systems that are simpler, where it's harder to shoot yourself in the foot, we can actually get pretty far. If we can design software that runs on rocket ships, then I think that we can figure this out. Another challenge here is that incentives are really hard to get right. So we see this with the cryptocurrency Bitcoin. So Satoshi invented Bitcoin, and he imagined that everyone would participate in verifying this network. We would all be equal, and we would do so to retrieve awards in the system. So he kind of imagined this network in which one CPU equaled one vote. Now, what's ended up happening instead is humans have thought very hard about how to get more money out of this system, and we've seen a completely unexpected hardware market develop. So there's, I told you earlier in this talk that, you could go become part of the Bitcoin system. Technically, that's true, but effectively, that's not true, because the people who are part of the Bitcoin system use very specialized hardware called ASICs, application-specified integrated circuits. This is a data center full of ASICs. This is kind of what Bitcoin has become. It's become these really large miners who are participating in the network who have very specialized hardware. This hardware costs on the order of thousands of dollars. And it's more efficient the more of it you can get and the closer to a good source of energy you can get, because it's also very energy hungry. Satoshi didn't predict this at all. He had no idea that this was going to happen. And this, I think, is pretty much inevitable when you try to design a system with incentives. You're going to get something wrong. People are going to be more ingenious than you expected. We're still learning how to do this. And another sort of unintended side effect of what's happened with Bitcoin is that it's estimated to use the same amount of energy as the entire country of Ireland, which is really worrisome. And it is tens of billions of dollars, but it's nowhere near being a truly significant part of our world economy. And for a technology like this to scale, it can't use this much energy. I really believe that. So this is something that really worries me. And I think it's something that's going to need a lot more work, which is sort of designing these systems effectively. Another challenge with these systems is replicating existing inequalities. So there have been crowd sales to purchase these tokens. And the idea is that these crowd sales are very democratic. Anyone can participate. Anyone in the entire world can buy into these crowd sales as long as you have a computer and the ability to get some of the cryptocurrency that they're going for. So there was a crowd sale not too long ago for this token for this new internet browser called Brave. They raised $35 million in 30 seconds. which is just incredible, I think. It's this whole new method of funding. But when you look at exactly how that funding went, you find that, first of all, there were people paying a tremendous amount of money to skip the line, so to speak, to get in early. This sounds a lot like investment bankers and IPOs to me. And also that the top 20 addresses in the token sale actually control over 2/3 of the currency. For a lot of these currencies, the security model is predicated on the fact that there isn't a majority ownership of the coins or a majority ownership of some other resource in the system. So this is really worrisome, and I'm kind of afraid that we're replicating some of the problems with our existing systems in these cryptocurrencies again. But as long as we can recognize that, I think that we have the ability to fix it. So I'm very excited about the direction that this field is going in. I think that what we're doing is we're seeing the power of peer-to-peer and open systems. So just like with the internet, we were able to have this really simple interoperable layer, and then on top of that layer, we were able to build all sorts of amazing applications like email and video chat and messaging. I think that in the future, we'll view cryptocurrencies as the layer of something kind of like the internet of value about transacting in digital assets. So that's all that I have. Thank you very much, and happy to take questions.
All right, so we will be taking questions at boston.eaglobal.org/polls. I'll be watching out for those. We've got a couple coming in already. So I'll play the dummy here for a second. Not hard for me to do. So I think I generally get Bitcoin as kind of a construct. I think probably most people who are here have at least a general understanding. But the first question that came in, which is one that I was also kind of pondering, is how do some of these other applications work? Like Bitcoin was kind of designed to be a store of value, a currency in a sense, right? But then you had one up there that was about file storage.
Yeah.
So help us bridge that gap from currency to file storage. Like, if I'm going to put my files in this, where are they going to live, and who's going to ensure that I can get them back, and who buys into that? You know, that leap is something that I think a lot of us probably don't understand.
Yeah, and to be fair, I think that we are in the middle of solving that challenge right now. So it's not that I can describe an answer and a working system. It's more like, I think it's possible. But the basic idea, and there are people working on this. So there are a couple of different companies which are looking at how to incentivize something called a DHT, a distributed hash table, which is a mechanism for storing keys and values. And then another company which is looking at file storage. And you know, it's interesting. So in Bitcoin, the token is actually used in a couple different ways. So it's a store of value. It's a mechanism for payment, but it's also the way that you pay fees to make the system work. And it's also the way that you incentivize security in the system. So miners are incentivized to build on the chain that they think that everyone else will build on, because that's the only way that the Bitcoin that they get to mint out of nowhere is actually worth something. Miners get paid fees in Bitcoin, and again, they have sort of this investment in making this token worth something. So for a file storage system, you could kind of imagine paying fees in some token in order to retrieve your files. And a lot of this is based on this idea of cryptographic proofs. Can you prove that you're storing a file for me? Can you prove that I retrieve that file successfully? And if you can use cryptographic proofs to do some of these things, then you can do that exchange of value for the service. But like I said, I think this is still a very open area. It's very exciting. There's still a lot to be done.
So, and maybe the answer is we don't know yet. But continuing on this file storage idea, it doesn't feel like something that I would necessarily want to be super open. I mean, I guess my files can be encrypted, so even the person who's storing it can't read it. But people can sort of blip on and off of this network. And maybe they can prove something today that they can't prove in the future, right? But that's not so bad if they're just taking their own Bitcoin and going away with it. But for some of these more sort of advanced applications, how do we think about that kind of worry?
Yeah, so first of all, I don't think that this technology is for everything. Like, I don't think it's going to replace Dropbox, and I don't think that Google and Amazon are going to throw away all of their disks and instead use something like this. But I think that it could potentially have some benefit. So one benefit, which maybe isn't the main one, but is the fact that you don't have to set up and run your own system. You can become a part of this existing system. You don't have to sign up for an account. You don't have to register with a credit card. You don't have to get like an Amazon account and sign up for AWS. Some of these systems, anyone can just join as a peer. Another sort of thing that's very nice is that because we've unbundled some of the layers in the stack, you end up with this need to define interoperability between the layers. So if I'm storing my data, and there's a project at MIT called Solid, which is trying to envision new protocols for user-owned data. One of the companies I keep talking about is called IPFS, the Interplanetary File System. If I'm using a sort of a decentralized data storage layer like this, it kind of forces some level of standardization and interoperability between the layers, which I think could be really beneficial. But again, I don't think this is going to replace Dropbox. There's still, I think it only makes sense in very certain situations.
Gotcha. A couple questions coming in from the audience. What do you see as kind of the key criteria for new coins to be successful, and what is the role of government in this space? There's, I think, a lot of confusion about, can the government shut this down? Is it truly beyond anybody's control or not?
Yeah, so I think the government definitely could shut it down if it wanted to. These systems aren't as robust as we like to believe they are. However, I also don't think it's in government's best interest to shut it down. From the conversations we've had, people are interested. They want to see what's going to happen. They don't want to stifle innovation. They don't want to destroy the seedling technology that potentially could be the next internet. So they're kind of willing to sit back and watch and let the private sector figure it out a little bit. That said, in particular with these initial coin offerings, when these tokens go up for crowd sale, I think we're probably going to see some action on that pretty soon. We'll probably see, definitely I know regulatory bodies are looking at it. They're worried about consumers getting scammed. And I think probably what we'll see develop before the government gets involved is the community will come together and kind of decide on a set of best practices for how to issue these things in a way that's fair. For example, locking up coins so that the developers who did the initial coin offering can't access them for a long time. Having voting rights. Right now, these things don't really come with any rights whatsoever. They're actually like strictly worse than equities for investors. And so I think we'll see this evolve and standards evolve.
Interesting, yeah. The trust problem sort of gets kicked up a layer at some point, but it kind of remains on some level too.
Definitely, yeah.
So another question. Apparently The Economist had a piece that argued that blockchain technology in general is really going to be a boon for existing financial institutions, and that they will, it's sort of ultimately going to be something that they're going to control and sort of use to remake themselves, but not something that will lead to broad decentralization. Thoughts on that argument? Yeah.
Well, there certainly are a lot of large institutions that are jumping on this bandwagon, the blockchain but not Bitcoin bandwagon in particular. They kind of rebranded it digital ledger technology and are now forming consortia to try to use it. Personally, I mean, a centralized database is almost always faster and cheaper than a distributed one with many different copies that require many different participants. So I don't really see this replacing core financial infrastructure of these large banks. I think if they want to build message passing systems that make it easier for them to reconcile data and work together, that's great. But they're all pretty scared of the idea of a different token, a different currency. And so I think they're really missing the boat. I don't think they're going to control it at all.
What, maybe the last question, because we're just about out of time. Are you going to be at office hours today? Do you have a session?
At
Do you know
3 o'clock.
3 o'clock, okay, perfect. What applications are you personally most excited about for blockchain technology?
Yeah, that's a great question. So one thing that I'm really excited about is the work that we're doing with financial inclusion. And part of the reason I'm excited about it is because it's so ultimately simple technologically, yet potentially could have broad effects. And that's about using this technology to deal with issues of fraud. In economies and systems where there isn't really you can't really trust the data that's being generated, can we design systems which can make that data more trustworthy? Because what I've found, talking to a lot of different people who work in development, that's a fundamental problem that potentially could change the lives of a lot of different people. If you can make data more trustworthy, if you can incorporate different types of data into things like measuring creditworthiness, then you can unlock capital for a whole slew of people. And so I find that concept very, very powerful.
Awesome.
Yeah.
Neha Narula, thank you very much. Catch her at
Thanks.
office hours at
Okay.
3 o'clock.